Okay, problem number 5 on the practice sheet. We're going to jump right into it for these rational functions. We want to possibly factor and possibly cancel. We can definitely factor, and I can already tell we're going to be able to cancel here. So this x plus 3 will take out that x plus 3. Be careful with what's left over because the numerator is not blank. All right, so this is f of x is equal to 1 over x plus 1. So now using that simplified function, I'm going to find the x, y intercepts, the vertical and horizontal asymptotes, and obviously we have a hole since we canceled something. All right, y-intercept, set x equal to 0. So 1 over 0 plus 1 is equal to, well, 1. So 0, comma 1. X-intercept, I want to set the numerator equal to 0, and my brain just fries when it sees that short circuits kind of, and I immediately write none. All right, there is no x-intercept there. Vertical asymptote, set the denominator equal to 0. So we have a vertical asymptote of x is equal to negative 1. Horizontal asymptote, this is that weird situation where these degrees don't match. Right? Clearly we have the larger degree in the denominator. So what happens here is as you get further and further away from the origin, either negative or positive, this is going to pull you, right, 1 divided by some large number is going to pull you closer and closer to 0. All right. We do have a discontinuity, so I'm going to take x plus 3, set that equal to 0. So my x value is going to be negative 3. And then my y value, f of x is the same thing as y. So y is equal to 1 over negative 3 plus 1. So 1 over negative 2, so negative 1/2. That should be my discontinuity. All right, so I'm going to take this information and stick it onto a graph here. Let's see what we got. So 0, 1 for my y-intercept. No x-intercept, so I'm not going to worry about that. Let's go ahead and put some asymptotes on here. X equals negative 1. It's going to be this vertical asymptote right there. Y equals 0 is the x-axis right here. We have a discontinuity at, let's see, negative 3, 1, 2, 3, negative 1/2. So I'm going to kind of zoom in so I can really graph this well, or as good as it's going to get for me. All right. Extra point is not needed in this case because we have 1 point to the right and then we have the discontinuity to the left. So that gives me everything I need to graph this, except possibly the artistic ability to do so. Let's see what I can do. All right, so I'm going to approach that discontinuity, but remember, don't draw through it. And then, wow, apparently Notability doesn't like me right now, so let's see if I can get this to curve. Ooh, there's the curve. A little wobble to it, but that's okay. All right. On the right side here, coming in, we're going to curve through that point, approach the asymptotes in both directions. All right. So that's problem number 5. And again, that's that goofy problem where your degrees did not match. Higher degree in the denominator means that you have a horizontal asymptote of y is equal to 0. I'm going to go ahead and stop this one, and you'll see problem 6 and problem 7 show up in 2 separate videos.